So just to summarise the points I've made on summary statistics, then for continuous data, if you think the data's got a fairly symmetrical distribution, an example of that would be temperature is often fairly symmetrical, then you can measure location using the mean. To get the spread of individual values, then we've got the standard deviation, the accuracy of a mean, which is related to the standard deviation. You could measure that by the standard error or the 95% confidence interval, which is the interval within which 95% of the time you would expect the mean to lie. If you've got a measurement, a continuous measurement, but it's non-normally distributed or it's got quite a skewed or odd distribution, then the median can be more appropriate, and then you would summarise the spread of the data by these quartiles that I mentioned, and also you could give the range if you felt a bit more information was needed about the distribution. We've just looked at time to event data when the event may or may not happen. So if you've got sufficient data and there's a fixed follow-up period, then the median is a good way to summarise it. And again, if you've got sufficient data, you could use quartiles, but you need to be sure that the follow-up period is the same for all the data. Binary or categorical data, then the proportion or percentage can be used, and we can also calculate standard error to measure the accuracy of that and a 95% confidence interval. And then ordinal data, we've got the choice of presenting either proportions of observations that have each of the values or we can obtain the means. And I'd say if you've got more than 5 categories, that can be a neater way to summarise the ordinal data. And if you get the means, of course, you can get the standard deviation as well, but for both standard error and the 95% confidence interval can be used to measure the accuracy of the proportions. So this is really just giving you a flavour for next time when I'll be looking at simple statistical tests to compare groups. A few slides back we saw some summaries of the cases and the normal curves, and we saw that platelets was very different between them, but it didn't actually prove anything. We're just saying, yeah, we've got the mean and they look different. But often what people want to do is say, are we absolutely sure those differences are going to occur if we did the study again? And that's where an actual statistical analysis comes in, and it can be tested using something called a hypothesis test. And if you've done a bit of statistics before, you'll have come across something called the p-value. And the p-value is quite critical because it tells you if you've got what might be defined as a significant difference or not. So basically, what defines the p-value is it's a probability that there is no difference between the groups of data. So you've got a set of 2 groups, and you want to see if the means of the 2 groups are different, they look different. The way you go about testing that is to say, well, let's assume that they're not different at all. What's the probability of that? And that is calculated as the p-value. So for this probability that there's no difference is very small, and typically people say if it's less than about 0.05, that's taken to indicate a significant difference between the groups. So what it's saying is there's less than a 5% chance that these groups are the same. So that's what we'll be concentrating on next time when we look at various different tests for comparing groups of data.